Hello, I welcome you all to your own channel MSK Learnium. Now in this video we will see the green theorems, right, in a plane. So what is green theorems? We see here that if S is a closed region in a xy plane bounded by a simple closed curve C, and if M and N are continuous function of x and y having continuous derivation in R, that is a real number, then the line integral of m dx plus n dy is equal to double integral of over the surface dou n by dou x minus dou m by dou y dx dy, where C is a traversed in the positive directions, right? So now what is that? If any surface is given in a closed region xy plane, right, which is bounded by any curve, right, and that curve should be the closed curve, right, and m and n are the continuous function of x and y, then that line integral of m dx plus n dy is equal to double integral of dou n by dou x minus dou m by dou y dx dy is a green theorems, right? So we will see the green theorem with one working example, and then we can also know that how to verify the green theorems, right? So one problem on the screen, please see this, that verify the green theorem in plane for line integral of 3x square minus 8y square of dx plus y minus 6xy, sorry, this is there is a mistake, right, plus 4y minus 6xy dy, where C is the bounded region by y is equal to root over of x and y is equal to x square, right? So you have to verify the green theorems where the function is given that 3x square minus 8y square plus 4y minus 6xy of dy, where C is the bounded region by y is equal to root x and y is equal to x square. So y is equal to root x is nothing but the x is equal to y square and y is equal to x square is the parabola equations, right, on x and y plane. Now so how we can verify the green theorem? We will see here that you can write solution that first of all we can, whatever the bounded region is given, I will show you. Just wait, sorry, yes. So this is what you have here you can see, that is y dash x and x dash, right? So we have a two curve is given, that is y is equal to root x and y is equal to x square. So first of all this is what you have this is for your y is equal to x square, right, y is equal to x square, and similarly you have this is equal to y is equal to root over of x, is it or not, right? So y is equal to root over of x. If you look at this is intersecting at a point 1, 1, right? So let's say this point is the A, right, that so then you can say y is equal to root x and y is equal to x square. This is the parabolic curve, right, on xy plane. Now you need to find out that we have to verify the green theorems, right? So first of all we have a curve is what, that line integral of, again I'll show you the question, the line integral of 3x square minus 8y dx plus 4y minus 6xy dy. So if you compare this with the green theorem what we have discussed just now, that is line integral of m dx. So dx m is what, m is nothing but by comparison you can say m is equal to 3x square minus 8y square and plus n dy, that is n is nothing but the 4y minus 6xy, is it or not? So now we can write that here let m is equal to 3x square minus 8y square and n is equal to, that is 4y minus 6xy, is it or not, right? Then you can find out the dou m by dou y and dou n by dou x, right? So first of all I am finding that dou m by dou y. So dou m by dou y means what, this is m, so you have to partially differentiate with respect to y, so it will be 0 and its differentiation is minus 16y, right? Similarly you have to differentiate the dou n by dou x also, right? So we can say it here, that is dou n by dou x. So dou n by dou x means n is this one, so this will be 0 and its differentiation is minus 6y. So this is what you have, a minus 6y. So dou m by dou y and dou n by dou x we got. Now we can apply the what we call, that is green theorems, right? So here we go, that you can write right. So now you can write that green theorem is what? That Green's theorem. So what is the green theorem? That line integral of m dx plus n dy is equal to surface integral of, that is dou n by dou x minus dou m by dou y, is it or not, into dx and dy, right? So now you can say here that double integral of what? Surface of, this is dou n by dou x minus dou m by dou y, all right, into dx into dy, right? So now this we have to simplify, that is double integral of, so that is equal to what? Dou n by dou x you already got, which is minus 16, right? Sorry, that is minus 6y, and minus dou m by dou x is nothing but a 16y. So minus minus plus 16y into dx into dy, right? So this is what you have, minus 6y plus 16y is nothing but the 6y, right? So you got this, sorry, that is 10y, right? So this is what you have, a double integral of 6y into dx into dy, right? Now again you can say, sorry, this is not 6, that is 10, right? So this is what 10 you can get common. So this is what you have, a 10 you are getting common. So you have to integrate that x is equal to 0, right, and x is equal to 1, and the surface is what you have, a surface is given, that is y is equal to x square, right, and y is equal to root x, is it or not? So this is what you have, a 10 we have taken common, so it's y into dx into dy. Alright, so first of all we have to integrate with respect to y, so its integration is y square by 2, right? So now you can say it here, that is 10 integration from x is equal to 0 to 1, right? And this is what you have, a y square by 2, and this is lower limit is x square and the upper limit is root x, right? So now further you can substitute this limit, and this is what you have, a dx, right? So while you substitute the limit, that root x, y square is nothing but the x by 2, right, and minus x to the power 4 by 2, right? So 2 we can get common, so it will be 5, right? And this after simplification is what? X minus x to the power of 4, right? So I hope you know this calculation. So what is that? Further 5 into integration from 0 to 1 x minus x to the power of 4 into dx. So now you can simplify and get this, that is x integration is what? X square by 2, so this is 5 x square by 2 minus x to the power of 5 by 5, limit from 0 to 1, right? So while we put 1, so this is what you have, a 1 by 2 minus 1 by 5, and this is 0, so no problem. So 5 into, you can say 1 by 2 minus 1 by 5, right? So on simplification you'll get this, that is, this is what you have, a 3 by 2, right? So this means you got the line integral of m dx plus n dy is equal to 3 by 2. Let's say this is, or you can write it here, that is line integral of m dx plus n dy is equal to how much? Is equal to 3 by 2, right? So let's say this is equation 1, means this is the one value we got. Why? Because why I'm taking 1? Why? Because we have to verify this green theorem, right? So for verification, whatever the value we'll get, that should be also 3 by 2. If it is okay, then we can say the green theorem is verified, right? Now we can go for the verification. So here we go. So this is what you can say, that verification. So how you can verify this? Let's see. That for verification you can say the line integral along y is equal to x square plus line integral along y square is equal to x, right? So line integral, you can say that is what, line integral of along y is equal to x square plus line integral of y is equal to y square is equal to x, right, along the curve. So this you can say this is as a I1, right, and plus I2, right? Now so I1 we can find first, that, sorry, here, yes. So I1 is equal to what, you can say I1 is equal to integration from 0 to 1, right? And this equation is what? Equation is nothing but you have a 3x square minus 8 y square, right, into dx plus 4y square, sorry, that is 4y minus 6xy into dy. This is mdx plus ndy into the form, right? So x square is equal to what? X square is equal to x only, and y square is equal to x. Why? Because for line in y1 we have considered y is equal to x square, right? So can I write this equation like that? That is, this is equal to 0 to 1, 3x square minus y square is equal to x to the power 4. So minus 8x to the power of 4 into dx plus this 4y is equal to x square, right? So this is your 4x square minus again y is equal to x square. So this is what? 6x cube. All right, 6x cube, right, into dy. So now if you see that y is equal to what you have, y is equal to x square. So dy by dx is equal to what? 2x dx, right? So dy is equal to, you can write sorry, that is dy by dx is equal to 2x, right, and dy is equal to 2x dx, we can say, right, that dy is equal to 2x. Okay, now then dy is equal to 2x dx we will substitute here. Then this equation will become, that is what, this is equal to integration from 0 to 1, 3x square minus 8x to the power of 4 dx plus 4x square minus 6x cube into dy is equal to 2x dx, right, 2x dx, right? So on simplification the simple integral is there, right? You have to put the limit from 0 to 1, you'll get the values is what, that value is nothing but, or you can further simplify and then do the calculation. So this I1 is equal to we have a minus 1, right? Now we can go for the I2, right? So I2 is equal to what? That line integral of y square is equal to x, right? So this equation will be become, that is, it is from 1 to 0, right? Then it is what? 3x square minus 8y square, that y square is equal to 8, so it is 8x only, right, into dx plus y is equal to what? Root x. So this you can say 4 root x, right, 4 root x minus this is what, 6x to the power of 3 by 2 into this dy is equal to, you can substitute 1 by 2 root x dx, right, 1 by 2 root x dx, right? So on simplification this integral you have to simplify this simple integral, so the value is 5 by 2, right? Now what we have, the total integral is what? The total integral is I1 plus I2, that is nothing but minus 1 plus 5 by 2, it is equal to what? It is equal to 3 by 2. So if you can see that from that 1 and 2, that is, this is equation 1, you can say, right? So from 1 and 2, right, that is what? M line integral of m dx plus n dy is equal to surface integral of double integral of surface over dou n by dou x minus dou m by dou y into dx dy is verified, right? Verified, right? Why? Because in both the cases we'll got the 3 by 2, 3 by 2. This is how you will solve the Green theorem problems and you can also verify. Thank you.